Okay, last but not least here, before we wrap up for spring break, is the area of rhombi, or the plural of rhombus, and kites. Okay, and to find the area of a rhombus or a kite, you can take 1/2 times the length of both diagonals. Okay, so those line segments that are drawn between two non-consecutive vertices, multiply those together and then multiply by 1/2. Okay, so here we go. Some examples. Here, 8 represents one diagonal, 15 is another. So I'm going to do 1/2 times 8 times 15, maybe, for an area of 60 meters squared. Okay, here, this rhombus, don't forget a rhombus is a parallelogram, so its diagonals do bisect each other. So if this is 10, this over here is also 10. So that diagonal is 20 feet long. Okay, if this is 12, this is also 12. So this diagonal is 24. And so we're going to take 1/2 times 20 times 24 for an area of 240 feet squared. Okay, number 3 is much like number 4. The length of this whole diagonal going from top to bottom, 6 and 6 is 12. Diagonal going from left to right, 7 and 7 is 14. And so I am going to find half of the product of 12 times 14, which is 84 millimeters squared. Okay. Now, example 4. We got a couple things to do before we can actually find the area. Okay. The first one here. Ooh. We are going to focus on this blue triangle here. Okay, because this is a kite, our diagonals are perpendicular to each other. Okay, so when I look at this triangle first, I see 6, I see something, and I see 10. Okay, so I'm going to use the Pythagorean theorem. We've got 6 squared. Nope, nope. Try this again. Plus x squared equals 10 squared. Okay, you should find that x is 8. So this portion and this portion are both 8. Okay, now we've got a second right triangle to look at. Right here. Okay, and that right triangle, we've got 8 here. We don't know what this part is, but we know that that part is 17. Okay, so I'm still doing the Pythagorean theorem. 8 squared plus what squared equals 17 squared? You will find that that portion is going to be 15, right there. Okay, so the length of my diagonal here the shorter of the two. 8 and 8 is 16. Okay, the length of my longer diagonal, 6 plus 15 is 21. So to find the area of this kite, I'm going to take 1/2 times 16 times 21 to get you an area of 168 square inches. Okay? Whew, take a breath. They don't all involve that much Pythagorean theorem. Okay? Now, example 5, we are going to have to work backwards. Ooh, excuse me. Dropped my pen. Okay, so first off, I am given the total area. Okay, so I'm going to work backwards from there. My computer wants to cooperate with me. Okay, so my area is 340. One of my diagonals is 20. I don't know the other one. Okay, so first off, I can go ahead and multiply here. Okay, I don't necessarily have to, I don't have to distribute because this isn't a plus sign. All right, so I'm going to go ahead and take 1/2 times 20 and simplify that right side a little bit. Divide both sides by 10, and that tells me the length of the whole diagonal is 34. Okay, but we don't want the whole diagonal, we just want half of the diagonal, and so we need to cut that in half, and that will tell you that x is 17 centimeters. Okay. All right, so one diagonal of a kite is 4 times as long as the other diagonal. Okay, with these, doesn't necessarily what you make d sub 1, d sub 2. Okay, but say d1 is x, the second diagonal is 4 times as long as the other. Okay, so 4 times as long, 4x. Okay. Okay, so again, I'm going to start with this equation. And I'm going to fill in the bits and pieces that I know. Okay, I know the area is 72. I know, oh goodness, no. One of the diagonals is represented as x. The other one is represented as 4x. Okay. So when I take 1/2 times x times 4x, I definitely get x squared. And then 1/2 times 4 is 2. So I have 72 equals 2x squared. If I divide both sides by 2, I get 36 equals x squared. Find the square root of both sides. X is 6. Okay. Now x only represents one of the diagonals. Okay, 4 times 6 tells me the length of the second diagonal. Okay. Last example here. One diagonal of a rhombus is twice as long as the other. Okay, so pretty similar. We let one diagonal be x. The other diagonal will be 2 times that. Okay, the area of the rhombus is 169. What are the lengths of the diagonals? So, start with our equation. Okay, fill in the parts that we know. We know the area is 169. One of my diagonals is x. One of them is 2x. Okay, lucky enough, my 1/2 and my 2 cancel on the right side. So now I've just got 169 equals x squared. Find the square root of both sides. We find x to be 13. Okay, but we don't want just the x value. We want the actual lengths of the diagonals. So one diagonal will be 13 meters. 2 times 13 is 26, so the other one will be 26 meters.